This is lesson 12.2, surface areas of prisms. Your objectives are to find lateral and surface area of prisms and cylinders. Find the lateral and surface area of each prism. Round to the nearest tenth if necessary. Here we have a triangular prism. For the lateral area, we'll use the formula L equals pH, where P is the perimeter of the base and H is the height of the prism. The base is a triangle, so we need the perimeter of that triangle. We know two sides of the triangle. It is a right triangle, so I can do the Pythagorean theorem to find the third side. 8 squared plus 5 squared equals c squared. So 89 equals c squared. And when you square root both sides, c is the square root of 89. So the square root of 89 will go right there. So for the perimeter, we'll do the square root of 89 plus 5 plus 8, and that's about 22.43. The height of the prism is the distance between the bases, which is 10. And now I can multiply that together, and the lateral area is 224.3, and that'll be feet squared. Remember, P is the perimeter of the base. I had to do the Pythagorean theorem to find the missing side, and H is the distance between the bases. For total surface area, we do the perimeter of the base times the height of the prism plus 2 times the area of the bases. Well, this much I've already found. That's my lateral area. So I can substitute in my lateral area number, which was 224.3. And then 2 times the area of the base. In this one, the base is a triangle. For a triangle, area is 1/2 base times height. The base of the triangle is 8. The height of the triangle is 5. So the area of the triangle will be 20. That 20 is what goes in for big B. Remember, big B is the area of the base. What shape is the base? A triangle, and that's when you do the area of a triangle right there. So when I put all that together, the total surface area is going to be 264.3 feet squared. So use your lateral area right there, and then 2 times the area of the base. Find the lateral area and surface area of each cylinder. Round to the nearest tenth. So we'll use the lateral area formula. L equals 2 pi RH. The radius of this cylinder will be 2. The diameter is 4. The radius is half that, which is just 2. The height of the cylinder is 8.5. Remember, the height is the distance between the bases. In this one, it's 8.5. When you work that out, you get 106.8 meters squared. For total surface area of a cylinder, use the formula 2 pi RH plus 2 pi r squared. The radius is 2, the height's 8.5, and the radius is 2 again. Punch all that in, and you get 131.9 meters squared. Use the formula, substitute in the correct value. We didn't know the radius, so we had to find it, and then punch it all in. Make sure you hit the pi button and not 3.14. This is lesson 12.3, surface areas of pyramids and cones. Your objectives are to find the lateral areas and surface areas of pyramids and cones. Find the lateral area and surface area of each regular pyramid. Round to the nearest tenth if necessary. For the lateral area of a pyramid, the formula is half the perimeter times the slant height. For this one, the base is a pentagon. One side of it is 5 feet, which means the perimeter, if you count all 5 sides, that'll be a total of 25 for the perimeter of the base. And the slant height is the distance from the center of a side of the base up to the vertex, and that we know, and that'll be 13. And that's a grand total of 162.5, and that'll be feet squared. P is the perimeter of the base, L is the slant height. Substitute it all in and work it out. For the total surface area, we'll use the formula T equals half perimeter times the slant height plus the area of the base. Well, we already know the perimeter and the slant height from the lateral area, and now we need to know the area of the base. Since the base is a pentagon, we're going to have to do the area of a regular polygon. The area of a regular polygon is half perimeter times apothem. Well, the perimeter is still 25. The apothem, remember, is the distance from the center to the edge. And if you get your apothem chart for a pentagon, the apothem is equal to half a side times the tangent of 54 degrees. A side on this one is 5, so we'll substitute 5 in for S. And that's what goes in for apothem. 5 halves times tangent 54 is 3.44 approximately. So that will be our apothem. And when we punch all that in, the total area of that pentagon is about 43.01. We could just call it a 43. So, for big B, we'll substitute in 43. And we get a grand total of 205.5 feet squared. So to find the area of the base, for this pentagon, remember to do the area of a regular polygon, get your apothem chart, and work it out. Find the lateral area and surface area of each cone. Round to the nearest tenth if necessary. First, we'll do lateral area. Lateral area of a cone is pi times the radius times the slant height. We don't know the slant height here, but it is the hypotenuse of a right triangle, and I know the legs, so you can do the Pythagorean theorem to find the slant height. One leg squared plus another leg squared equals the slant height squared. 16 and 25 make 41. When you square root each side, the slant height is the square root of 41. So that's what we'll substitute in. Pi times the radius, which is 4, times the slant height, which is the square root of 41. And when you punch that in, you get 80.5 meters squared. So since we didn't know the hypotenuse there, which was the slant height, we did the Pythagorean theorem to find it, and then we substituted in the correct value. For the total surface area of a cone is pi RL plus pi r squared, adding the pi r squared there to get the area of the circle base. Well, the radius is 4. The slant height we found a minute ago, which was the square root of 41, which remember we did the Pythagorean theorem to find it. And then pi r squared and that gives you 130.7 meters squared. So substitute in the values, use the same numbers that you did for lateral area, and then throw on the area of the base at the end. This is lesson 12.4, volumes of prisms and cylinders. Your objectives are to find the volumes of prisms and the volumes of cylinders. Find the volume of each prism or cylinder and round to the nearest tenth if necessary. Here we have a triangular prism. The volume of a prism is the area of the base times the height of the prism. On this one, the base is a triangle. So I need to do the area of a triangle to substitute in for big B. Area of a triangle is 1/2 base times height. But I don't know the height of the triangle. However, it is a right triangle, and I know two sides. One side is 10, and the other one here is 26. And you can do the Pythagorean theorem to find the third side. 10 squared plus, we'll use b for the base, squared, equals 26 squared. So 100 equals b squared, or 100 plus b squared, equals 676. Subtract 100 from each side. B squared is 576. And when you square root, b is 24. So that will go in for the base of the triangle. Half of 24 times the height, which is 10, and that's 120 meters squared. That will substitute in for big B. The height of the prism is the distance between the bases, and that will be your 17. So the total volume is 2,040 meters cubed. So the base was a triangle, had to find a side of the triangle there. So use the Pythagorean theorem and then substitute it all in. Here we have a cylinder. The volume of a cylinder has the formula pi r squared h. Well, the radius of the cylinder is half of the diameter. We know the diameter is 16, so the radius must be 8. And the height of the cylinder is the distance between the bases, which is 17.5. So the total volume of 3,518.6, and that will be millimeters cubed. So take half of the diameter to get the radius and substitute everything in. This is lesson 12.5, volumes of pyramids and cones. Find the volume of each pyramid or cone round to the nearest tenth. Here we have a pyramid. Volume equals 1/3 area of the base times the height of the pyramid. Since the base is a rectangle, we'll find the area, which is base times height for a rectangle. The base of the rectangle is 25 centimeters. The height of the triangle is 12.5 centimeters. So the area of the rectangle is 312.5 square centimeters. We'll substitute that in for big B. The height of the pyramid is right there. You know it's the height because it gives you the right angle, so it's perpendicular to the base. And that's a 23. The total volume is 2,395.8, and that'll be centimeters cubed. So substitute the values in. Remember, big B is the area of the base, so the shape of the base is a rectangle. Do the area of a rectangle, substitute it all in. Here we have a cone. The formula for the volume of a cone, V equals 1/3 pi r squared h. Now we know the height, which is 12 millimeters. We don't know the radius, but we do know that acute angle of 52 degrees. And since we have a right triangle, we can do some trigonometry to find that missing side. The radius is the adjacent side. The height is the opposite side. So we can use tangent. Tangent theta equals opposite over adjacent. Theta is 52 degrees. Opposite is 12. And adjacent is your radius. And remember, when the variable is in the denominator, you can switch it out with the other side of the equation. So r moves to the other side, and tangent 52 moves to the denominator. So the radius is about 9.375. So that's what I'll substitute in. Back up here, volume is 1/3 pi 9.375 squared times the height, which is 12. Work that out, and you get 1,104.6 millimeters cubed. So since we didn't know the radius, we had a right triangle with one of the acute angles. We did some trig using tangent to find the missing side.